Alright, we're starting with 6. Meter stick in a passing spaceship has a length of 0.97 meters. What is the speed of the spaceship? And notice they want it, they're looking actually for the coefficient of v. So v equals something times c. What I suggest, whenever you see that, when you say they want the answer is v blank c, think of actually as that blank equaling v over c. All right? So if you kind of bundle these together, I find it easier to think of mathematically. So this is number 6. And of course we know that length contracts. And by length we mean physical dimension in direction of movement. And in this case, the meter stick measures 1 meter in the ship's frame of reference. But less when observed from Earth frame of reference. So this is all, of course, due to speed of light constant. All in all frames of reference, right? So equation-wise, let's see, things are moving, so I need my Lorentz transformation here, and I'm looking at length. So it'd be good to have equations that had length in them. See if I can grab that again. Oops. I didn't want that one. That one messed up. There you go. That one I don't want. Let's see. Let's get rid of that one. Alright. So, I have my Lorentz transformation here, and I know, how is gamma always related to the number 1? Well, let's see. How is B always related to C? Is it always greater than C, equal to C, or less than C? It's always less than C. So a smaller number over a bigger number, how's that related to the number 1? Be less than 1. Less than 1 squared? Still less than 1. 1 minus a number less than 1? Less than 1. I think I'll just face you because it's you and I having this conversation. Square root of a number less than 1? Less than 1. 1 over a number less than 1? More than 1. So how is gamma always related to 1? Always more than 1. A little mathematical logic there. And we know that the meter stick measures more in the ship's frame of reference than the Earth's frame of reference. And since gamma is always greater than 1, we know that L is always greater than L naught. Is that true? Oh. No. If you don't believe me, take a number, divide it by 2, and then see if you get a bigger or smaller number. Or 3. Or 297. Or 1.1. So in our case here, we know that it's longer in the ship's frame of reference, so L naught must be the ship, and L must be the Earth. And now it's just substituting in, right? But you want to, one thing I'm going to do is group that B and that C together so that so we have it. So I'm going to say length from the Earth, which they told me 0.97 meters, I think. Yep. That's going to equal 1 meter times square root of 1, and I'm going to group that B and that C together because really what I want to finally solve for is B over C. And that will be the answer that they're looking for. Because they want B in terms of C. So, there you go, that's it. Okay, so we're going on to 7. Oh, wait a minute, it's exactly the same as 6. Okay. Do we need to do it? No? Yeah, it's like identical to 6, isn't it? They're even looking for the speed. So, all right, let's at least look at 8 before we. Yeah. All right, let's look at number 8. So in number 8, oh, this is like exactly from the article that you guys read, the chapter from the book, right? That, well, I hope you read. And so we've got the speed of light being very slow. We have a bicycle ridden at a speed close to that. And seeing someone from an outside frame of reference is observing it. And in the bicycle frame of reference, the bike is certain length. So very similar to number 6 that we did, or 6 that we did, but a little different. So the length, I don't think I need to redefine length of bike is shorter due to motion, due to C being fixed. And since there's things moving, put it up again. Okay, we'll deal with it. Let's see, we know from last time that L is always less than L naught. So this must be from the observer's, we'll call it the Earth's frame of reference, and this must be from the bike's frame of reference. Right? And the only difference is this time, we're told, for me, that B is 21 kilometers an hour, and that C is 24 kilometers an hour. I think is how it's set. Up 25, sorry, and 1.87. And I'm given the length, the bicycle is 1.87 meters. And now you just substitute in, right? Just like when you did number 6. Yes, no, yeah. Yeah, I think the trickiest part is identifying which is which, and we've done that, so if you get an answer greater than 1.87 meters, you did a math mistake.